Hey everybody, it's just time now to do a quick video on adjacency matrices and networks. So let's get into it. All right, we have a network here. First up, we're going to go network into an adjacency matrix. Right, this network has 4 vertices, vertex A, vertex B, vertex C, and vertex D. So I've drawn my brackets over here big enough so I can fit our rows for A, B, C, D, and of course our columns A, B, C, D. Now, if you remember your matrices, this place up here reads, how many ways can I go from vertex A to vertex A? This one says vertex A to vertex B, from A to C, from A to D. All right, let's go fill out this table. Vertex A, down here. There is no way I can get from A back to A. There's no line, no edge, sorry, that goes from A to A. So in our matrix, we would put 0. A to B, on the other hand, there's one edge which goes from A to B, and here's another edge that goes from A to B. So up here, I'm going to put a 2. Working my way through A to C, you can see there's only one direct way which I can get from A to C. So A to C is 1. A to D though, I cannot get in one step all the way to D, can I? So that one has to be a 0. All right, now we've got vertex A out the way. Vertex B, from B to A. Let's have a look. B, that one goes back to A, and this one goes back to A as well. So that one is going to be 2. B to B, is there any way I can go from B to B? No, there isn't. B to C, B, there's C, there's one edge that goes that way. And B to D, I can get to D this time, directly up there from B all the way up to D. So I'll put a 1 over here in the matrix. Vertex C turn. C to A, there is one way direct there. C to B, there is also one way directly there. C to C, nope, can't do it. There's nothing there which can go back to C, so that's a 0. And C to D, up that way, there is a 1. All right, now D. Oh, just before we go on to D, let's have a look what's happening here. We've got all 3 zeros there. You see, we've got no way we can get from the vertex back to the original vertex. So normally they'll all be zeros, but you notice what's happening here. That B and that B is 2. Then we go 1, 0, 1. 0, 1, 1. What do you think is going to go down there? Let's check. D to A. If that's symmetrical around that line, which so far it is 0, 1, 1, 0, that should be a 0, shouldn't it? D to A. Can I get from D to A? No, I can't. Good. Well, that's 0. Now, check this next one out. 1, 0, 1. That should be a 1. So D to B, yep, D to B is a 1. Most of the time, all the time, these are going to be symmetrical when the networks are not directed. All right, when there's no arrows, you're going to end up with a symmetrical matrix. So if this value over here, D to C, if C to D is 1, that means D to C is also going to be 1. There it is. Okay, this is where we've said the vertex to the vertex was 0, 0, 0. This one is going to be different up at D because have a look here. We've got a loop. Okay, so please remember, loops are always counted in a matrix as 1. So we need to put a 1 over in this corner. All right, pretty straightforward. Great. Let's have a look the other way now. Adjacency matrix, turning that into a network. Okay, so we have a 3 by 3. So that means I'm going to need to put 3 points on there. Well, rather first, I probably should label this matrix, rows and columns again. I'm just going to use A, B, and C, and A, B, and C for the rows. Please, it's a good idea to make sure that you name them. If, for example, you've got 3 cities, Melbourne, Brisbane, and Sydney, label them M, B, and S, and make them meaningful. All right, so I've just used A, B, and C because I haven't got a scenario. So first thing I need to do is I need to draw 3 vertices. There's A, there's B, there's C. Now, it doesn't actually matter where they go. I've just drawn them in a line here. Talk about that more in a minute. So A, B, and C. Let's have a look. To put our edges in, we're going to look A to A. So it says 0. So that means there's no loops. A to B, that means I can't go from A to B because it says 0 there. But A to C, I've got a 2. So I have to draw, there's one line going from A to C, and a second line drawing A to C. Again, doesn't really matter where you draw it. It's a good idea to not have things cross over if you can avoid them. All right? So I could have drawn this up the top there. That would have been equally fine. So there's 2 ways, 2 paths that go from A to C. Let's have a look at the B now. B to A. B to A, there's 0. B to B, I've got a 1 there on the B to B. So yes, that means there is a loop. There's a loop around B. B to C, there's one way I can get from B to C. There we go. Let's check the last row. C to A is 2. Oh, I've got 1 there and I've got 1 there already. So that's 2, that's good. C to B, I've got 1. And C to C, there's nothing there. So that one's finished. Now, you remember I said it doesn't really matter where you draw the vertices? Well, it's true. I could have drawn the vertices in a different way. There, I've drawn them in a line. Down here, I've drawn them in an L shape. I've done the A and C over there. I could have done the A and B there. But you can see that there's 2 from A to C. So there's your 2 from A to C. You've got 1 from B to B, which is there. And you've got 1 from B to C, which is there, which means it's all going to match up. That means this graph here and this graph here, they are isomorphic. They're the same. Just another word to remember. One suggestion I would have, though, I said it before, try not to cross the lines. If you can separate your vertices like this bottom one here, it's much easier to see that this is a planar graph. Okay, there's discrete areas. There's no lines that cross over. You could, if I had drawn that B up here, for example, there would have been the line which goes C to B, which crosses over here. And it's much harder to see if you have lines crossing over or things embedded inside a pair of lines to see that it's planar. So try to space things out. Don't jam it all into a small spot. Okay, that's that. If you've got any questions, ask your teacher. Otherwise, let's go. Matrices and adjacency networks. Sorry, wrong way around. Adjacency networks and matrices. That's very hard to say. All right. Have a good time with it.